Okay, anti-differentiation is essentially doing the backwards thing of differentiation, thus anti-derivatives. There's another name for it, which is called integration. And I'll mention a bit more about that in a second. So, if dy dx is equal to x to the power of n, then when you integrate it, or if you anti-differentiate it, you get this. Now, if you think about it, when we have 5x, when you differentiate it, you get a 5. But does 5x plus 1, when you differentiate it, give you the same answer when you differentiate it?
Yeah.
5x plus 3? Yes. What that means is this part here, the number part, actually doesn't change the derivative, but when we're trying to anti-differentiate it, we need to find this number, in which we call a constant. So if you have a look on here, there's a plus c. That's what this plus c is. This plus c is, it's known as an arbitrary constant. Arbitrary means it can be any number, so it's just a constant in other words. Now you need to put that plus c in when you normally put it in. So, some symbols for you to have a look at later. It will pop up in between. This is the integral sign. That's not complete yet, by the way. That's called the integral sign. It's one of the reasons why I say the other name of it is integration. And you have the function in there like this. Then see how there's a dx here, which tells you that you're working stuff in respective to x. That's why this dx is here. You're integrating in terms of x. Now at some point you may have to learn about differentiating with different variables, and that's why you need to know what variable you're working with, which is why you need to put that dx in. Then usually the integrated part is f of x, like this. Any questions? It all looks a little bit weird. Don't worry, once we start doing it, you'll find it's really, really straightforward. Now, just a key note. Note that this is dividing down here, which is an n plus 1. And on the top here, you also have an n plus 1. Okay? If it doesn't make sense to you yet why it's n plus 1, just remember on differentiating we take the power down. So this power is a 1, so we take it down, we get a 1, then we subtract the power by 1. In other words, whatever power you had will need to be divided, which is why it's n plus 1, and you need to make sure you add the power by 1. Yes? Anyone puzzled? Was it fairly straightforward? Alright, so A, if dy dx is equal to 6 times 8 to the power of x to the power of 8, find y. So, y is the same as the integral of 6 times 8, x to the power of 8 squared. That's a mouthful. Dx, because we're integrating with respect to x. If we add 1 to the power, what do we get? 9, so there should be a 9 down there. What should we put on the top? A 9 again. So remember, we're just adding the power this time, and we're dividing it by that number. And then don't forget your plus c. Like so. What's 6 over 9 when it's simplified? 2/3? Sounds good. Okay? Is that fairly straightforward? Same thing as anti-differentiation. Oh, sorry, differentiation. Wrong word. You would actually anti-differentiate everything term by term. You see why I use the word integral instead, and from now on I'm going to use the word integral instead of anti-differentiation because it's a mouthful, so I'm just going to use integral. You integrate each one separately. So this one, what do you get? What do we divide it with? Because we're adding the power by 1. 3, good. And what goes on the top? 3, good. This one? What do we divide it with?
2.
There's a 1 here if you're not sure, so that's a 2. And this one?
1.
Yep. So we can write divided by 1, but I'm not going to. Then, is there anything we can simplify?
Yeah, the 3/3.
Good. Not that tough? That's what I'm saying, we can do a few things in one go. Alright, do you want more examples, or do you think it's okay? Because I might skip the first one. Yeah? Because the first one looked exactly the same as the one before, so I'm just going to skip it. Yeah. Okay. B. Calculate that integral. Well, what did we do before when we were differentiating? Because you're going to do the exact same thing. Split it up. Yep. Then divide your powers. Well, it's 5 minus 1. 4. This one will be a 6. So then 7 over 5 times 5, x to the power 5, minus... Is anyone confused if I just write the times 5 or do they need to see what happened? Yes? No? Maybe? Can I get an answer? No? Okay. 8 over 5 times 7 plus C. Fairly straightforward, yeah. Now, C, you need to do a little bit of manipulation. We want to find the integral of 3 over 2x cubed. What do we need to do first to make our lives easier? What do we do whenever we have the x on the bottom? We always have to convert the x to put it on the top. So we just change it to a negative. So 3 over 2, I may have skipped a step. 3 over 2 times 1 over negative 2, because we added it by 1. Be careful with your negatives. People always get it wrong because they're not thinking. Then if you want to change it, you can. I'll write down the change version, but otherwise it's fine to leave it as the line before. Yeah? And then D. Oh god, I'm running out of space. Find that integral. Well, there is something that you can learn next year. I'll let you do it. If you look on the Year 12 summary sheet that I may have given to you at some point, it actually shows you how to do this one, but I'm not going to tell it to you, so we have to expand it. So what do you get when you expand this? You should have an x squared. What's x times 1 on x? 1. How many of those are there? 2. Okay? And same thing as before, change a fraction. Then work out your different bits. Okay. Okay. All good? Any questions? Alright, so when you're trying to find functions for the antiderivative, I said before that you have a plus c on it, and now we need to find it. So what you'll be given is given the derivative and a point. So once you've found, so step 1, you would find the integral where f of x is equal to the integral of f dash of x. Then, step 2, what do you think you'll do once you found it? Yep, you just find c. So sub in x, y into f of x to find c. Fairly straightforward stuff. I might only do the first one because the second one's the same. Alright, the gradient of a curve is given by that, where a is a constant. Given the curve has a stationary point at 2, 5, determine its equation. Now, you can actually already find a given that equation. How do you do that? What does that mean again? What 0?
The gradient.
Yep, the gradient 0. So that means 0, we can sub x equals to 2 into the derivative. So we get 0 equals to a plus 3 times 2. So a is negative 6. So then the y dx is negative 6 plus 3x. Then we integrate that. Then we substitute it in. So 5 equals to negative 6 times 2 plus 3 times 4 over 2 plus c. What's that? Negative 6, so 11. So once you figured it out, just simply write down the equation. I'm going to switch the order because I don't like having the lower power in the front. And there you go. Oh, sorry, plus 11. Yes, thank you, plus 11. Thank you. All good? Yeah? Can I keep moving? Alright, now you can use this to find graphs. You might see that I've crossed something out. I would suggest you cross that out when you're doing the questions as well, because it tells you to draw 3 random graphs where you just shift it. You may as well find the final one and then graph it in one go. So what you'll be given is you'll be given a graph, then you just have to go through and find all the different bits. What's the stationary point on this?
0.
Because this is the y equals f of x. 0, 0. So f dashed of 0 is equal to 0. And anything else? Whoops, that's actually wrong. Alright, just to clarify, this is actually the derivative graph. This is not the actual full graph, if you're a little bit confused, like I was just then. So f of 0 is 0, so that's a stationary point. Specifically, what type of stationary point? if it's going from positive to 0 to positive. So positive to 0 to positive. It's a point of inflection. This is a sign diagram for it. This is not the actual graph. That's all I was saying, this is confusing. What's the other point that's given on there? So f of 1 is equal to 3. That means f dashed of 1 is equal to 3. Okay? So now, we presume that this is a quadratic, correct? For f of x. So let's presume that. And specifically, this quadratic, if you have a look, has a turning point in the middle. So we can use the turning point form. Does anyone remember what the turning point form looks like? Yes. There's a HK, yes.
Minus.
Very good. Then, is that done? What are we missing? Very good. See, nothing that you guys have forgotten. Alright, what's our H and K in this case? What's our turning point in this case?
0 and 0.
0, 0. So these two are going to be 0, so we're left with ax squared. So if you look up here, that one actually tells you how to find it. You just sub in 3 and 1. So 3 equals a times 1 squared, so a is 3. So then f of x is equal to 3x squared. Now remember, that's a derivative, not the full graph. And yes, I don't like it how this textbook keeps switching in between small f and capital F, but that's where you have to be careful. This book uses small f as your gradient function and then big F as your actual function. So make sure you go back through and work it out. So big F of x is equal to the integral of 3x squared. So we get 3x cubed over 3 plus c, which is nice and easy because then you just get an x cubed plus c. Then if you read here, given that f naught is -2, sub that in. So nice and easy. Then f of x equals to x cubed minus 2. How do we sketch that? First of all, what does x cubed look like? Yep, it's a positive cubic, and then we shift it down by 2, so it goes to here, that's your flat point, then it goes back up. Sorry guys, I know it's long. Almost done, we're on slide 7 out of 10. Alright, last bit. This is a simpler bit. Once you understand how an integral works, this just tells you how to find the area underneath the graph. And all you need to do is substitute points, but note that the plus c disappears because you have the same function. So the plus c here and the plus c here, see how there's a subtraction? You're going to subtract the two so that plus c disappears. In other words, you're going to integrate it, find what they are, and then you just sub in the values. You'll see this more in year 12. I'm going to get you to do it this year, but you don't really need to fully stress about it. But it's nice to see it this year, and then next year when you see it, you'll be like, oh, okay, I know what it is. Alright, so evaluating that, what's the integral? You will work out the integral. Now see how there's two different values? You're going to sub those two values in, and then you're going to subtract the first one with the second one. So here we go. 3x squared plus 1 dx. We're going to integrate it. So we get x cubed. I should probably do that. Plus x. Now, you leave the numbers on the outside to tell yourself that you're going to put those numbers in. So this is an x cubed plus x. and you have to use square brackets. Then, now sub the numbers in. We're going to sub in 2 first. So we get 2 cubed plus 2. Then you're going to subtract the other one where you sub in -1. -1 cubed plus -1. Like so. So that's a 10 minus -2. So it gives you 12. So that's the area underneath. Okay? Is that fairly straightforward? You integrate it and then you sub the numbers in. Nothing too difficult. Alright, last little bit. The area underneath. So you have a graph of y equals to 2x. You're going to find the area underneath. You can do this via triangle because this one's a linear one. Sometimes you can't, so we need to be able to use the integration method. So we're going to test out both. So A, calculate the area of a triangle. What's the area of a triangle? Good, half base times side. As you can see, you guys are all falling asleep, so I'm going to speed up the head. 32, so 16. So that's our area. Okay, part B. Let's figure out the definite integral. Now, what points are you going through? 0 and 4, correct? So they're the points that you're going to put in on the top. Now, make sure you put in the largest number on the top and then the smaller number on the bottom. Next year when you do it, you might have an area underneath and then you have to switch the numbers and stuff so that you can add them. I won't worry about that for now. Just put the biggest number on the top and the smallest number on the bottom for now. Okay? Don't think about anything else. Then, what's our function? 2x. There you go. We've written down the definite integral. Then, hence, calculate the area. Integrate it. So x squared over 2, 4 and 0, running out of space. Sub in 4 and sub in a 0, so 4 squared minus 0 gives you 16 units squared. So there you go, it works.